Hey everyone, and welcome back to the channel. Today, we're diving deep into the fascinating world of AI agents powered by large language models, or LLMs. You've seen LLMs generate text, answer questions, and even write code. They're pretty amazing, right? But what if these powerful models could go beyond just responding? What if they could think, plan, and act autonomously to achieve complex goals? That's the big promise of LLM agents. We're moving past simple chatbots to sophisticated, intelligent systems that can adapt, learn, and solve real-world problems. In this video, we're going to unpack the foundational architectures and crucial design patterns that make these agents tick. We'll explore game changers like ReAct, the power of Retrieval-Augmented Generation, or RAG, and the critical role of self-reflection. We'll also touch on how these patterns come alive in leading frameworks and what the future holds. At the very core of every AI agent, the large language model functions as its brain or central controller. Think of it as the director, orchestrating the agent's entire workflow. This LLM is responsible for understanding language, drawing upon its vast pre-trained knowledge, and most importantly, performing complex reasoning and planning. But a standalone LLM has inherent limitation. It's trained on static datasets, meaning it often lacks access to real-time, dynamic, or highly specialized information. This can lead to what we call hallucinations, where it generates plausible but factually incorrect outputs. To truly function as an agent, the LLM brain needs external support. This is where other key architectural components come in. The perception module. This is the agent's sensory apparatus, allowing it to see and interpret its environment. It translates raw data, whether text, audio, visual inputs, or sensor data, into structured, actionable information that the LLM can process. The memory module. Unlike traditional LLMs that are inherently stateless and forget information beyond their immediate context window, a robust memory system allows agents to retain and recall information over time. The action space and tools. This defines the range of operations an LLM can perform to interact with external entities and achieve its goals. Tools are essentially encapsulated code blocks, ranging from simple calculators and web search APIs to complex integrations with databases and other models. The LLM dynamically invokes these tools through function calls, allowing the agent to act upon the real world. These components don't operate in isolation. Their seamless integration and continuous interaction are what enable an LLM agent to exhibit intelligent, adaptive, and goal-oriented behavior. Now, let's get to the heart of how these agents are engineered. The development of sophisticated LLM agents relies on a set of recurring design patterns that structure their internal logic and interaction with external environment. One of the most powerful and widely adopted patterns is ReAct, short for reasoning and acting. This framework allows the large language model to alternate between explicit thinking and acting within a given problem context. It combines chain of thought, reasoning with the use of external tools, enabling LLMs to engage with the world beyond their internal knowledge. The agent first verbalizes its chain of thought reasoning step. This internal monologue helps the model break down the larger task, plan its approach, and track its progress. Based on its current thought, the agent decides on an external tool or operation to perform. It outputs a specific format, typically a function call with parameters, to invoke this tool. The result returned by the invoked tool or the environment is then fed back to the LLM as an observation. This provides critical, real-world feedback that the agent incorporates into its next thought step. This interleaved thought-action-observation process creates a continuous feedback loop, allowing the model to iteratively problem-solve and dynamically adjust its approach. ReAct agents can work with a wide variety of external tools and APIs. The dynamic nature of tool selection allows ReAct agents to learn from past mistakes and successes, tackling unforeseen obstacles. ReAct significantly reduces hallucinations by grounding the LLM's responses in real-world data from external sources. This is a direct solution to a major LLM limitation. Frameworks like LangChain have integrated ReAct as a core functionality for building agents that leverage LLMs and various tools, while ReAct provides the how-to-act loop. Retrieval-Augmented Generation, or RAG, addresses the what-to-know problem. RAG is a key pattern for implementing semantic memory in LLM agents. It augments LLMs with external knowledge bases or databases to ground their reasoning and responses in factual information. LLMs are trained on static datasets, meaning they lack native access to current or real-time information. RAG overcomes this by allowing the agent to 1. Retrieve, search and pull relevant information from external knowledge sources like documents, databases, or the web, based on the user's query. 2. Augment, feed this retrieved information as additional context to the LLM. 3. Generate, the LLM then creates a response informed by both its internal knowledge and the newly retrieved up-to-date facts. This process directly contributes to reducing hallucinations by anchoring LLM responses in stored facts, mitigating errors that arise when LLMs try to fill knowledge gaps. It's essential for applications requiring high factual accuracy and access to proprietary or frequently updated knowledge. Another critical design pattern is self-reflection, often referred to as self-critique or self-refine. This empowers LLM agents to analyze their own outputs, identify potential issues, and implement necessary improvements autonomously. The underlying mechanism allows agents to engage in a continuous, iterative cycle of criticism and rewriting, progressively enhancing their performance. Reflection, a prominent framework. Reflection provides agents with textual feedback based on their performance, enabling them to learn from their mistakes and improve their actions in subsequent attempts. Reflection typically involves an actor, LLM, generating output, an evaluator scoring it, and a self-reflection, LLM, generating verbal cues for the actor's self-improvement, storing these experiences in long-term memory. The world of LLM agents is rapidly evolving, driven by ingenious architectural designs and powerful patterns like ReAct, RAG, and self-reflection. These aren't just buzzwords. They are the fundamental building blocks that enable LLMs to transition from reactive tools to truly autonomous, intelligent systems capable of planning, acting, and learning. The continuous innovation in frameworks demonstrates that LLM agents are poised to redefine how we interact with technology and automate complex tasks across every industry. What are your thoughts on these agentic architectures? Which pattern do you find most exciting? Let us know in the comments below. If you found this video insightful, please give it a thumbs up, share it with your network, and don't forget to subscribe for more deep dives into the world of AI. Thanks for watching, and I'll see you in the next one.